Greek lesson. I don't know if any of you speak Greek. I don't speak Greek, but I know enough words, I think, to get us started. The idea here is I've got 5 pictures on the screen. We're going to try to figure out what these have in common. I've got the guy from the board game Monopoly. We've got a guy wearing glasses, but there's only one glass, which is called a monocle. The other 3 might be a little bit tougher to decipher. If someone is a really boring speaker, if their voice is really flat, and we call that a monotone. So we have monopoly, monocle, monotone. Maybe you're seeing the theme. If you print a photograph in one color but different shades, we call that monochrome. Chrome means color. And the last one is these are kind of the 3 large religions, Christianity, Islam, and Judaism, that all only have one God. And the term for that is monotheistic. So I've got monopoly, monocle, monochrome, monotone, and monotheism. And all of those share a Greek root. So a lot of words in English come from Greek or Latin. These words all come from Greek because they share that root mono, which just means one. So mono means one or single. If we move along in our presentation, I've got 3 more pictures. Again, you might have an easier time identifying these. I've got a bicycle. I've got some computer code, and if you can see on your screen, it's only zeros and ones, which we call binary. And then here's an airplane. It's a type of older airplane, and we call it a biplane. So you have a biplane, bicycle, and binary. You've probably kind of clued on to this. Whenever you see that word, bi, it means 2. So a bicycle is 2 wheels, a biplane is 2 wings, and binary is a way to express numbers, but using only 2 digits, so 0 and 1. We call it binary. So I've got mono means 1 in Greek, bi means 2. My triangle is blocked here. I was trying to show a picture of a triangle. A tricycle, which you might have ridden before. You had a bicycle. And then this is a dinosaur. What type of dinosaur? Well, this is a triceratops, which we know because it's got 3 horns. So mono 1, bi 2, and then tri is 3. And the last Greek root that we're going to need to know for this unit is, what do these 3 share in common? This one's actually a little bit trickier, a little bit more abstract. Any shape, no matter how many sides, we can call a polygon. This is a picture of a place that people often go for really nice beach vacations. It's in the South Pacific, and it's Polynesia. And then this one, if you have many spouses, you get married many times, it's called polygamy. So poly is the Greek root of these share, which means many. So poly could be 1, it could be more. So Polynesia, I think, means many islands. Polygon means many sides. And polygamy means, I think it might mean many wives or many husbands or many spouses. I'm not exactly sure, but I do know that poly means many. So we're going to now use those 4 words, mono, bi, tri, and poly, and apply them to math. I'll move my face out of the way. I'm still kind of learning how to do this embedded webcam, which hopefully adds something to our video lessons. So this unit, we're going to be looking at polynomials, which you would have looked at in grade 9 as well. Again, poly means many, could be 1, could be more, and nomos means term. So polynomial means we have multiple terms. A term in math is anything that is separated by an addition or a subtraction sign. So a monomial means something that only has one term. So I'm just going to get out of presentation mode. A monomial has one term. So for example, just a number, minus 47, that's a monomial. So it only has one term. Same with 3x squared y cubed. Because there aren't 2 different terms separated by a subtraction sign or addition sign, that's just one product, one term, so we call it a monomial. A binomial, which of these only have 2 terms? If you want to play along, you can pause the video to check. Negative 5x plus 3, it's got 2 terms. So the first term is negative 5x, and the second term would be positive 3. So remember, a term, the sign in front of the term goes with it, and then 7 subtract 2x is also a binomial. I've got 2 terms. I've got 7, and I have negative 2x. Trinomial, which is about as long as we'll get in this course, is 3 terms. So for example, x squared plus 3x plus 8, that might look familiar. That looks like a parabola or a quadratic relation in standard form, but it's a trinomial. I've got 3 terms. I have x squared, I have positive 3x and positive 8. And this last one just looks a little bit funkier. I think that would give you some kind of 3-dimensional graph. But again, it's got 3 terms. So a term is anything separated by a minus or a plus sign. And the three terms that we're going to look at today are monomials, one term, binomial, two, trinomial, three, and those are all kind of subsets, or all examples of polynomials, which just means many terms. Okay, so that's kind of our vocabulary lesson. We're going to flip into doing some math, and we're going to start with a little bit of review. So we're going to work up today. Our topic for today is multiplying binomials. We're going to start, something that we're pretty good at is we can multiply a monomial, one term, by another one term. So 2x and x are both monomials. I multiply them together and I get 2x squared. So x times x is the same as x squared, so that's how I would write it. The next one's going to work the same way. I'm multiplying a monomial, 3xy, by another monomial, negative 7x. And what I'm going to do, and again, we made a practice with this, is I'm going to multiply positive 3 times negative 7 first. So it's going to give me a negative 21. Then I'm going to multiply my x times x is x squared. Then I've just got a y times, which is 1 or nothing. So I'll just still have a y. So that's how we multiply monomials by monomials. Should be something that we're pretty used to by now. And one way, a helpful way to think about this is first I'm multiplying the coefficients, then I'm multiplying kind of each variable separately. Another thing that should be reviewed that you've probably learned in grade 9, and we've done it a lot this year already, is how do I multiply monomial by binomial? So 5, well, that's just a monomial, but then x subtract 7 is a binomial. And we can multiply that with the distributive property. So I'm going to multiply or distribute that term in front of the brackets by everything inside the bracket. So I have 5 times x, which is 5x. And then I have 5 times negative 7, which is negative 35. So when I multiply a monomial by a binomial, my answer is going to be a binomial. Same thing here. Again, this should be things that we're familiar with. I'm going to distribute the term in front. So I'll have negative 2x times x, which is negative 2x squared. And then I have negative 2x times positive 5y. It's going to give me negative 10xy. So x times y, we can just write as xy. So that's kind of a quick review of things that we're used to, multiplying polynomials that we've done before. What's going to be new today is we're going to learn how to multiply binomials by other binomials. And again, I probably should have mentioned this at the start. There's a blank copy of this note in Google Classroom, so you want to print out a blank copy to follow along. If you don't have a printer or you don't have access to a printer, what we could do instead is you could just take down this note on lined paper. There really isn't a lot of writing. So if I'm moving too fast, you can always pause the video, give you a chance to write down the note. I'm probably moving a little bit quicker than I would move during an in-class lesson. But our goal today is to multiply binomials by binomials. And an example here is x plus 5, that's one binomial. And I'm going to multiply it by another binomial, x plus 3. So this should look a little bit different than what we've done before, but we're really going to use a lot of the same principles. So that's kind of the start of our lesson today, and we're going to just continue in another second. Okay, just had to grab some colored pens for this part. So we're going to multiply the binomial by the binomial, and what we're really going to do is we're going to distribute twice. So I'm going to distribute x by multiplying it by everything in the second bracket. I'm going to distribute the 5 by multiplying it by everything in the second bracket. So what I'm really going to do, and I'll just show you briefly the idea, is I'm going to distribute just like I would normally, but I now need to do this twice because I'm distributing both terms, or multiplying both terms in the first bracket by both terms in our second bracket, or our second binomial. And we have an acronym, which is going to help us remember how to apply this distributive property when we multiply binomials. So an acronym is when we use the first letter of words, or when we use kind of anything to help us remember something. So an acronym is when we use the first letter of the words, and then this is an example of a mnemonic. So a mnemonic is a way to remember something. You might know every good boy deserves fudge if you're some kind of music student. I forget what it is for the bass clef. If you know, leave it as a comment. But in math, when we're multiplying binomials, what we're going to do is first, I'll do these in different colors. So we'll do first in blue. So that means I'm going to multiply the first term in each bracket, and I'm going to do the outside. I'm going to go all the way from the first to the last. That was the second line I drew. Then I'm going to do inside, which would in this case be those two terms that are just next to each other. The 5 and the x are on the inside. And then finally we have last, which I'll just do in black. So first, outside, inside, last, we can say FOIL is how we're going to remember the distributive property. So on the next page of your note, or it might be on the back of your paper, I'm going to use FOIL to expand and simplify the example from the previous page. So I'll try to use those same colors. The first thing I'm going to do is multiply first by first. So why don't we write that there? So that's first, that's the F in FOIL. So x times x gives us x squared. Next, I'm going to do outside. So we'll do outside in red. So that's going to be, I'm going to go all the way first times last. My two outside ones are going to be x times 3, which will give me a positive 3x. Our next one, which was in green, will be inside. Positive 5 times x will give me a positive 5x. And then finally, we have last, where I'll multiply the last terms in each binomial or in each bracket together, which is positive 5 times positive 3, which just gives me positive 15. So I now have 4 terms because I've applied the distributive property twice. I've multiplied x by everything in the second bracket, and I've multiplied 5 by everything in the second bracket. I'm not quite done. I can still collect like terms. Remember, like terms are anything that share a variable and share an exponent. So x squared is by itself, but I can always collect these two middle terms. I can add 3x and 5x. I have x squared plus 8x plus 15. And we'll talk about this kind of as we go, but this might look familiar to you from the previous unit. It looks like I'm moving from factored form to something that looks more like standard form of a quadratic relation. So you can kind of already see the motivation for learning this. But today and in this unit, we're really going to kind of leave parabolas behind and just kind of focus on this algebraic toolkit. Let's do some examples together. Each time I'm going to use the first outside, inside, last, the FOIL method. So let's get started. So here's example 2a. Again, you're welcome to try these on your own, pause the video, and then come back and I'll go through the steps. You're welcome to watch a couple and then go away, and we're going to look at kind of a few different cases. So in our first one, I'm going to do first x times x, which give me x squared. And I'm going to do outside. We want to be careful of our signs. X times negative 1 is negative 1x, which we can write as negative x. Then I'm going to do inside. 5 times x is positive 5x. And I'm going to do last, positive 5 times negative 1, which will give me negative 5. So be really careful on your signs. And then our second step is always going to be to collect these middle terms. Negative x plus 5x's, I'm going to have 4x's, and then I have negative 5. So when I multiply these two binomials together, my first step is to expand, which means to get rid of the brackets by multiplying, and then I'm simplifying, which we notice means collecting all of my like terms together. If you do it in this order, first, outside, inside, last, we're often or always going to end up collecting the middle terms. But it doesn't matter what order I multiply these in. So you can experiment with what you're comfortable with, but in the end, I like listing my terms, my squared term first, then my linear term, my term is just an x, and then my constant or just a number. Okay, let's move on to B. First, x times x. Outside, x times 2, 2x. Inside, and then last, 1 times 2 with positive 2. And then I'm just going to collect the only like term to those two in the middle, 2x. I add another x, I've got 3x plus 2. Okay, so that's it for FOIL. Our first step is to do kind of 4 multiplications, and then our second step is to collect the like terms. We're just going to look at a couple different cases now, and then you're going to have a chance to practice with some textbook questions. We have x minus 6 squared. What does squared mean? Squared just means I'm multiplying something by itself. 2 squared is 2 times 2. That means x minus 6 squared is x minus 6 times another x minus 6. And it's really helpful to write that out. Now I have two binomials that I can multiply together the same way that I've been working. X times x, I go first. Then I'm going to go outside. X times negative 6 is negative 6x. A positive times a negative is a negative. Inside, negative 6 times x is negative 6x. And finally, my last, negative 6 times negative 6 is positive 36. And then I'm going to collect negative 6x, subtract another 6x. I'll have to take away 12x plus 36. Okay, so if I've got a squared binomial, it's really helpful to write it out twice, and then I can apply FOIL. What I don't want to do, and I'll put maybe like a warning, x minus 6 squared does not equal x squared minus 6 squared. So I can't just apply that squared inside the brackets. This is a really common error that I want you to avoid. Instead, I want you to write out the binomials, because otherwise I'm going to miss that important middle term of subtract 12x. I'm just going to work through a few examples. Again, I have a squared binomial, so I'm going to write it out. It's x plus 1 times itself times another x plus 1. I'm not always going to draw those arrows, but you're welcome to. I'm going to have x squared plus x plus 1. And if you want to slow that down or do the FOIL step on your own, I encourage you to look at where these numbers are coming from, and then I collect in the middle. So again, if I have a squared binomial, it means I have to multiply the binomial by itself. Squared, or any power, is telling me how many times I need to multiply something by itself. In example E, I now have a coefficient on the x, but nothing else is changing. So I'm doing first, 2x times x is 2x squared. I'm doing outside, 2x times positive 4 is positive 8x. I'm doing inside, negative 3 times x is negative 3x. And then I'm doing last, negative 3 times positive 4. A negative times a positive gives me a negative. And now I want to collect. 8x's minus 3x's, I've got a positive 5x. Subtract 12. And we'll do one more similar example. I've got coefficients on both x's, so let's just be a little bit careful. And again, you might want to stop the video and try this on your own first. 4x times 2x is 8x squared. That's first. Then outside is 4x times negative 1 minus 4x. Inside, negative 3 times 2x is negative 6x. And then last, so it's the last term in each bracket. Negative 3 times negative 1 is plus 3. Okay, the middle terms I can collect. So I have 8x squared minus 10x plus 3. Okay, we're just going to do one last set of examples. The difference here, if you again imagine this as a quadratic or a parabola, I've got an a value that's not 1. So I've got a coefficient in front of the two brackets. What I'm going to do is I'm going to do all my work inside the brackets, and then at the end of the problem, I'll just multiply everything by 2, or I'll distribute the 2 at the end of the problem. And we're just going to make sure not to forget it as we go. So I'm going to do first, x times 2x is 2x squared. And do outside, x times negative 1 is minus x. And do inside, 1 times 2x is plus 2x. And then last, 1 times negative 1 is negative 1. Now I'm going to collect terms, just like I would normally do. I'm doing the same type of problem, but entirely inside the brackets. So negative x plus 2x, I've got 1x, subtract 1. And now to finish the problem, I'm going to distribute that positive 2 to all three terms inside my bracket, inside my trinomial. I've got 2 times 2x squared is 4x squared, plus 2 times x is 2x, and then minus 2, 2 times negative 1. So my recommendation, if we have something in front of my binomials, is to do the problem in brackets and then distribute at the end. I'm going to do the same thing here. This time I've got a coefficient of negative 1, or you can think about it as a parabola. It's an a value of negative 1. And I've got, another one of these squared binomials, so make sure that means I'm multiplying 5x minus 3 by itself. Okay, my next step is to apply FOIL. So first would be 25x squared. That's 5x times 5x. Then I'm going to have outside is minus 15x. Inside is also minus 15x. And then negative 3 times negative 3 for last will give me plus 9. Now I want to collect. So I'm doing all the same steps I would normally do inside the brackets. But at the end, I need to distribute that negative sign, which is really, and if it helps, you can always write that down as a negative 1. So I'm multiplying all three terms by -1. And all that's going to do is switch all my signs. So I have negative 25x squared plus 30x, because -1 times negative 30x is plus 30x. Subtract 9. Okay, so we've done 8 examples now of how to multiply binomials together. We're basically applying the distributive property twice, and we're using this acronym FOIL, first, outside, inside, last, to remember the 4 different multiplications that I need to do, and then I collect like terms. So you've got practice questions in your textbook that I put at the bottom of this page. I would try those next and then come back and watch our next video lesson. Okay, thanks for watching. And again, if you have any questions, please send me an email or log in during study hall today.